presentation is on exothermic reactions. And originally we had planned to do evolution, and then we planned to do light, and then we came back to something all of us love, lighting things on fire and watching sparks fly up into the air. Eli and Grady are going to talk more about exothermic reactions and sparklers and whatnot.
Alright, so I'm going to talk about sparklers and what's in them. So there's three main ingredients in sparklers, which are additional fuel, metallic fuel, and binder. The metallic fuel is ferrotitanium, which is used in most sparklers and creates yellow gold sparks. The additional fuel is, is potassium nitrate, and it is used to keep the sparkler going and burning. The binder is charcoal, which is used to bind it all together and
keep it solid.
Yeah, keep it in a solid state. Grady's going to tell you what all those chemicals do.
Okay, so I'm going to go over a brief explanation of what an oxidizer is at first. So can everyone see this board? Okay. Now, I'm going to go over what an oxidizer is. And I'm going to use an explanation that is not a sparkler. I'm going to be talking about thermite, which is very interesting to me. So we start off with our oxidizer, which is iron oxide, and we have our metallic fuel, which is aluminum powder. There is no way for me to write aluminum powder, so it's just going to be Al. So now this outer ring of this box is going to be our aluminum powder that is released to the air. So this is aluminum powder without an oxidizer. What would happen if I lit this on fire was only the parts that had access to oxygen would burn. This would cause it, if it even ignited at all, this would cause it to be very slow, much like a candle, and wouldn't be very destructive. Now, I'm gonna go over why the iron oxide is so important. It works as an oxidizer. The idea of an oxidizer, these little dots are going to be our oxidizer, is they help the fire burn at a steady pace from the inside and the outside. So, if we now add an oxidizer, so these little dots into it, if I were to light this on fire, it would burn all together. Not slow from the out to the in, it would burn in every direction. This happens because, I don't know the exact makeup of it, but this happens because of this. Okay, well, failed. Here's our iron molecule, and here's our three oxygen molecules. Now, it doesn't matter that these inside areas that don't have any oxygen want to burn, they don't have any oxygen. Because it's a metallic fuel, and metallic fuels are generally very violent and powerful, they're actually so hungry for oxygen and want to burn so badly that they'll actually rip the oxygen out of the iron. Now, this is an exothermic reaction because this creates a very large amount of energy that is released in the form of heat. That is what an exothermic reaction was. Explosives are very similar to exothermic reactions, although they release their energy in the form of a shock wave, which can damage things around them. Exothermic reactions are a little bit more subtle. Usually, they can be used for entertainment. In the case of our sparkler. Now, bear in mind this is a sparkler and not a corn dog. Here is our sparkler. It's gonna have a metal rod down it. Now, it has oxidizers. In this case, I don't know what the oxidizer is.
I'm assuming it's iron oxide, but I don't think it's iron oxide.
It also has binders. Now, the idea of binders is they keep it all together. I usually talk about binders turning them into solid, however, this is not always true in the form of black powder. Black powder has binders and it is still yet a powder. It also has its fuel. One of the fuels is actually sulfur. Now, you might think this is a bit interesting, and you would think that this would go all up at the same time if it was made of sulfur. Now, all things are different, as iron oxide is generally not used as an oxidizer as it's usually used in key purposes, as they all have their own augmentations. The reason why sulfur is used is because without the sulfur, it generally burns quite slow, even though it has a metallic fuel. Metallic fuels are usually violent, but in this case, it needs a little boost from the sulfur. I believe that's it. Now, again, part of this and what makes it an exothermic reaction is due to these all burning and then ripping the oxygen out of the oxidizers, it then heats up the ferrotitanium. This causes the ferrotitanium to actually spark off, creating a very beautiful effect and long-lasting effect. This is how sparklers work. Now, we do have a video of how they work on a more concentrated level. Now this is what people call a sparkler flare. Would you like to start?
Yeah, so this is what we spent making. It's a bit of a bad video, but we made this out of 20 sparklers taped all together. And
bear in mind, this is not an explosion, this is an exothermic reaction.
yeah, so it doesn't create a shock wave, it just lets off a lot of heat in the form of fire.
No.
And, well,
It
sir.
releases energy.
Yeah, energy in the form of heat, yeah. And so that's the one made of 20 sparklers, and people made them out of hundreds of sparklers. We're going to show one with 360, or 300, I believe. So sparklers can be made, or sparkler flares are made by just taping a whole bunch of sparklers together, usually with electrical tape because it works the best, and just when you light one, it burns them all at once, and since they have nowhere to go to the side, they shoot all their sparks and their energy straight up, and creating, I guess, it's kind of like a firework. It just shoots the fire up in the air, and
Due to an exothermic reaction, in this case, the sparkler is not exactly being very violent.
Mm-hmm.
It can be turned into a directional firework.
yeah,
Or
so
sparkler fountain.
yeah, sparkler fountain.
This is rough sketch.
Yeah. So, I guess
That's it.
That's it. Yeah, that's the presentation.